Okay, now today we are going on to addition and subtraction of vectors. Now, because this class you told me you do not take physics, so I'm going to teach you in a way that you do not take physics, but I will link back to physics. Is that clear? How the physics students will do it? Actually, it's equivalent. Okay, now all of you look at the board now. If I travel from P to Q, hello? Then I travel from Q to R. Can you see it's continuous? This is the resultant. That means I travel from, it's the same as I travel straight away from Q to R. Right, now I think you know how to use Word document and so on. You can translate the picture, right? Go another side. It's actually by a vector translation. Can you see it's how many units X, how many units Y? You translate. It's actually a translation. Just like you come from your house to here, it's actually a translation. Everybody clear? Now, when we add vectors, hello? It must be PQ, QR, that means the stop and the start must be the same for addition. Then this is the resultant or the vector addition. Now, what do I say? For example, if this is A, this is B, this is C, I will say A plus B equals to C. The resultant is C. Everybody clear with what I'm saying? Okay, let's take a look at page 176. All of you, page 176. Abort left Changi Jetty P for Pulau Ubin Q. Okay, so on and so forth. Alright? Now, this is the concept behind the addition of vectors. We can think of PQ as a translation. That means it's a movement. Agree? Okay? And moving from P to Q and subsequently from Q to R is the same as moving from P to R. Everybody clear? Now, how do I write this? If I want to write A, B, C, how do I write this? All of you look up. It must be P to Q plus Q to R, then it gives me QR. Now, can you see this one must be the same? That means you stop there, you start again for the addition. Because for subtraction is different. Everybody clear? Where you stop, you must start for the addition. Okay? Alright, so PR is called the vector sum or the resultant vector, and we use a double arrow to indicate it. Resultant is always indicated by a double arrow to say that this is the resultant. Okay? Alright, so that will be your page 176. Now, I'm going to tell you what it means by parallelogram law, rule, and use parallelogram and use triangles. Okay? For physics, right, we will use parallelogram. But it doesn't matter whether you use a parallelogram or triangle, it's the same thing. I will show it to you. Okay, all of you look up here, please. Please look up. Don't look at your book or whatever. Now, if this is vector A, and this is vector B, this will be the resultant A plus B. Okay, can you see? Here, here, then opposite. Okay, now, if I draw a parallelogram with A, B, now, I told you before, right? If it's parallel, it's still A, right? This is still what? B. They will use the diagonal. This is A plus B. That means all start from here, this is the diagonal. This is physics. This is the resultant. But if you see that if I block this out, right? If I cancel this out, I block this out. It's actually exactly the same. Do you know what I'm talking about? It's just that for physics, we like to use this. This is A and this is B. This is the resultant in the middle. You combine the two. Everybody clear? But can you see that even if I were to print off the top, it's still the same. It's B plus A plus B. It's commutative. It doesn't matter A plus B or B plus A. It's the same. Everybody clear? Everybody clear? Can or cannot? So from now on, I will not use the parallelogram law. I will use the triangle one. It's easier. But the triangle one comes from the parallelogram. Is that understood? Okay. Now, next I want to say this when we add is PQ, that means whenever you start you stop, right? Correct. You start must be where you stop, right? Okay, so let me just do again. PQQR. This is my PR, right? Okay. Now, this is for addition. I'll go through the example later. I just want to show you something first. Okay. Now, for subtraction, I teach you something easier. I don't want to follow the text, so it's very confusing. Okay. For subtraction, both vectors must start from the same place. Understand? Both vectors must start from the same place. Can you see this one is different? You stop, then you start. Okay, this one, both vectors must start from the same place. Then you join this thing. Now, depending on what they ask, if it's A minus B, the arrow will point to A, the first letter. Understand? A minus B. Understand what I'm talking about? Yes or no? What if I want B minus A? Then it will be the other direction. B minus A. It will always point to the first vector. Everybody clear with what I'm saying? Yes or no? So I repeat, for vector addition, start, stop, start. For vector subtraction, both must start from the same point. Then whether is it B minus A or A minus B, you got to see. You understand? We always point towards the first vector. Everybody clear? But if you can see, right, all of you look here. Can you see that if I have this plus this is B, right? All of you look up. All of you look up. I show you something. Can you see this plus this? The arrow is continuous. This is the opposite. So actually, this one must be B minus A, right? Because this plus this is this one. So this one must be this minus this. Agree? Okay, but if you cannot, you just point to the first vector will do. Okay, then, how do I write this nonsense here, okay? Now, if the resultant is AB, it will be OB minus OA. It doesn't need to be O. It can be PB minus PA. This one can be any point, but it must be the same point. Everybody clear? Can or cannot? Okay? Alright, now, what I've done is that I have gone through some things that is in the textbook and vector subtraction, vector addition. I will just go through the examples first. Are you all okay with, for the time being first? Can Can because I'm going to go through again and again and again. Okay? Alright, so repeat. Is OB minus OA or PB minus PA, or it can be QB minus QA, doesn't matter. Everybody clear? Okay? Alright. Now, let us all look at now example 4. All of you look at example 4. Okay? This is your example 4. Okay. I'll make it a bit bigger. Okay, can all of you look at this particular picture here? The diagram shows two vectors A and B. Okay, all of you look up, please. Please look up. Draw the sum of the two vectors A and B. Now, can you see this one is here? Okay, can? Now, what I need to do is actually this. You look at this, actually vector A. Can you give me the column vector? 2, 3, right? 2, 3, okay, good. What about vector B? 4 and what? 4 and 5, 4 and negative 5, right? Agree? Okay. Draw the sum of the vector AB. Okay. Now I'm going to use square paper. Alright, I'm going to use square paper. Okay, I'm not going to use the method in the textbook that they show some rubbish down there. Okay, all of you look up. Don't do. Now, A is 2, 3. So 2, 3. This is my A, right? Can you see it? Then B is 4 minus 1 is A plus B. Remember the first question, they want A plus B. So whenever you stop, you must start right. So 1, 2, 3, 4. 1, 2, 3, 4, 5. So this will be my B, right? So this will be my resultant. So this is my A plus B, right? Everybody clear? So can you see? I stop, then I start again. So this is the addition. This is my A plus B. Everybody clear? Can you see these two add up? This one is the opposite direction. Okay, huh? Alright. So that is the first question. Okay? Now, can you look at the solution that is given on page 177 at the bottom? Okay? At the bottom. Actually, it's exactly the same as what I have drawn. Everybody clear? I said I will only use triangle. I will not use parallelogram. Okay? Can you see I did the same thing then, which is A plus B. Just like what I've done just now. Okay? So, method 2 on the next page, I'm going to ignore. Okay? Now, let's take a look at part B or part 2. What did they say? Express AB and A plus B as a common vector. Now, just now we found A is 2, 3, right? What is B? Just now I cannot remember. 4 and negative 5. So, what is A plus B? 6, negative 2, right? Now, let's take a look at this answer here. If you look at A plus B, all of you look up. A plus B is this guy, right? Can you see it? I count. 1, 2, 3, 4, 5, 6. 6, negative 2. Can you see? It will be the same. Everybody clear? It cannot flop this rule because if not, it will be nonsense. Okay? Alright, next part. Part 3. Part 3 is actually some nonsensical questions. How do you obtain A plus B from A and B using column vectors already? We just add up the matrix now. The column vectors are no issue. Then find the value of magnitude A, magnitude B, and magnitude of A plus B. Okay. Now I'm going to show this. What is this magnitude of? Magnitude of A will be 4 plus 9. This is root 13, right? How about magnitude B? 16 plus 25, right? So what's this? Root what? 41, right? Okay, what about this? What's the magnitude of A plus B? 36 plus 4, right? This is root 40. Now, I want to know, these two add up, is it this one? Is it this one? The answer is no. Okay, all of you key in this, what's root 13? Give me to 3 6 8. Or rather, 5 truncate. Give me the 5 truncate.
3.06.
3.0?
3.6055.
6055. Okay, what about this?
3.60. No, 06.
Wait, you say copy it. Cannot be all the same. This one has 3, so cannot be 3 already. 不是。讲好好 say properly.
Okay, the first
来
one.
第一个 3 point.
3.6055.
Second one.
That one is 6.4031.
Add together please. Add together these two please. 10.008. That means magnitude A plus magnitude B is this one, right? Can you key in square root 40?
6.3245.
Now, can you see that they are not equal? Can you see? Okay, actually this one falls from Pythagoras theorem. The 2 square you add together is not that one. You agree with what I'm talking about? Yes or no? Can? That means what it means is this. All of you look up. I explain to you what it means here. If you look at the picture, hello? Okay. The magnitude of this plus the magnitude of this is not the magnitude of this. This is what it means. Correct? Yes or no? They are individual. Not, you cannot add together. Everybody clear? Okay? Alright. So, next part. What did they say? Is magnitude of A plus B equals to magnitude of A plus magnitude of B? Explain why or why not using the diagram that we have drawn. Okay. Let's look at the explanation here on the next page. Okay. Now, you will see root 13, root 40, root 41, like what I've said, right? So, this one is 10.0, this one, 6.32. Can you see? I've done it for you. Now, that means this is not equal to this. From the diagram, the 3 vectors, A, B, and A plus B form the sides of a triangle. Since the sum of the lengths of any 2 sides of a triangle is larger than the length of the third side, this is not equal. Okay? I think by common sense you can see that. Okay? The length is not this length. Everybody, okay? Yes or no? Okay, just like Pythagoras theorem, all of you now. You know this is a 3, 4, 5 triangle, right? Does 3 plus 4 give you 5? No, ma. From here already can see already. It doesn't work. Everybody clear? Yeah?
And lower the light. Very bright.
Very bright, huh? Okay.
My eyes gonna die.
Huh? You're going to be blind, huh?
Yeah, I'm gonna be blind.
Oh, you don't want to be blind, huh? Okay, lor. Nobody say I want you to be blind, lah. But 2 dot also will also be blind, no? Is this okay? Can? Okay, huh? Now won't blind, right? Okay, good. Okay, right? Next one. Let's look at the next one. They summarize for you on the next page. Okay? They summarize for you on the next page. Alright? Now please don't sleep. They have the triangular law and the parallelogram law. I'm going to use the triangle now. It states what I say. Ending point of first vector must be starting point of second vector. Everybody okay? Now, then we also learned that the magnitude of A plus B is not the same as magnitude of A plus magnitude of B. And we also have column vectors like that. This is just matrices. No need to worry about it. Everybody okay? Alright, so this is our vector addition. Okay, now I am moving on to example 5. Will that be okay? Alright, let me just make it a bit bigger. Example 5. Okay, now actually, I don't need to look at the diagram. From here, I can also see what is it. Okay, now let's go here. Now, I want to show you something first. That vector is actually commutative. Commutative means it doesn't matter which order. Now, all of you look up. Do you agree that this is the resultant vector? If I use this triangle, it's A plus B, right? If I use this other triangle, it's B plus A, right? Correct now. That means A plus B is the same as B plus A. It doesn't matter. Everybody clear? Okay, so it's called commutative. Okay, commutative means can flip around. Okay, now let's take a look at the first one. The diagram shows a quadrilateral simplified. Now, AB plus BC. I no need to look at the diagram of all of you. I also know that the answer is AC, correct? Because this is the intermediate point. So the answer is AC straight away. You don't have to write until so long with it. Everybody okay? Alright, now let's take a look at part 2. DB plus AD. Now, can you see that I can also write AD plus DB? I can write in either order, right? So final answer, AB. Okay. Now if you don't want, you want to look at the diagram, can. DB is here, right? Correct? How about AD? AD is here, right? Can you see it's here plus here? So the resultant is here, so it's AB. Can you see it means the same thing? Okay? Alright. Now, vector addition, regular law, okay. Last part. Now, I'm going to simplify this. I'll look up. AC plus CB is actually AB, right? First two. Then I plus BD. So the final answer is what?
AB.
AB. Alright, so no problem. I don't have to look at the picture. I will also know that the answer is AB. Are we clear here? Are we clear here? Okay, good. So this is on vector addition. Now, next. What do you mean by a zero vector? Okay? Zero vector means the thing never moves. Okay? Now, I want to show you something. PR plus RT. Do you agree that finally it's actually PP? Why is PD? It's the same point, right? So this is actually the zero vector. You must put a tweeter below. It's a zero vector. That means you move from P to R. Okay. Ladies and gentlemen, hello. Look here. You move from P to R. Then you move from R to E. You never move up. The resultant is zero. You never move. Okay? But distance-wise, I got move, Can you see that distance-wise, I move double this? Here and here. Total distance travel. Understand? That's why there's a difference between distance and displacement. I'm talking about this because kinematics. Chapter 18 will come to this of your KMS. Okay, now let me just illustrate this to you what it means. All of you look here. All of you look here. This is the origin, let's say. This is distance 30, this is minus 30. Okay, all of you look up. I have a particle A. I move from here to here. The distance traveled is what? 30. What if this particle move to here? Distance traveled is what? 30 plus 30 plus 30, It's actually 90, Can you see what I'm talking about? Hey, I'm talking to you, this is important. 30, 30, 30, right? So it's 90. But this is called distance. 90, let's say meters, okay? Now, what about the displacement with respect to O? It's actually negative 30 because it's on the left side and 30 meters. That's why displacement got direction. Displacement is a vector. Distance is a scalar. Everybody clear? Because distance you don't need to know direction. No? Displacement you must know direction with respect to which particular position. Everybody clear? Everybody clear? Okay, now, so this is a zero vector. Now, they want you to take note. Zero is called a zero vector. It is not a scalar. That means they bold it, right? Can you see in your textbook they bold it? So you must put zero like that. Okay, then it is a zero vector. Okay? Alright. Now, next one. Page 6. Not page 6. Page 182. Now, I think I don't need to do this. This is very simple, right? Can you see this is 0, 0 lah? Correct now. This is 0, 0. Then, of course, this one, I know how to fill in lah. 5. This one is negative 5, right? Then what is this? 2 lor. Then it will become like that, right? This is common sense, right? Okay? Then they say copy and complete. It's actually rubbish here. Okay? Now what does it mean? What does it mean? Why do they want to show you this rubbish, right? Okay. What they want to tell you is this. The next part. Can you see that when I take the vector A, I add the opposite of A, I will get the zero vector. Or I take the opposite of A, I add A, I'll get the zero vector. Correct? It's something like algebra, you see? Minus A plus A is 0. You understand? Because you go, come back, or come back, go, it's the same. It doesn't go anywhere, you're still there. Okay? Alright. So this is called the zero vector. Okay? Now next, vector subtraction. This is the one that I'm talking about. Difference of two vectors. Okay? Now, I will not use method 1. I will always use method 2. Okay? Now, I want to illustrate again. Can you see both vectors start from the same point? AB. Then, this is A minus B, so it points at A. Can you see what I'm talking about here? Okay, so this is called vector subtraction. Okay? Alright. Now, then, the question says this. Let's look at work example 7. Okay, I'm not going to go through that question, okay? First one. Draw the vector A minus B. Okay, can all of you look at the next page? On page 184, can you see they draw the vector A minus B already? Okay, next one. By looking at the diagram that you have drawn, express each of A, B, and A minus B as a column vector. I think there's no problem, right? You can express it as a column vector, am I right? Then the next question, how do you obtain A minus B from AB using column vectors directly? You just do the matrix subtraction. Okay, next one. Find the value of magnitude A, magnitude B, and magnitude A minus B. Are they equal? Of course, they will not be equal. Just like the addition one. Understand? Do you understand? Okay. Now, let's take a look at this conclusion on the next page. Okay. Magnitude of A minus B is not equal to magnitude of A minus magnitude of B. Okay. So, I am going to go through the subtraction again. Next page. Okay. Triangle law of vector subtraction. Both vectors A and B must start from the same point. Okay, this one is important. Okay, I want you to now look at example 8. I want to show you this. All of you look up. Don't do anything. All listen to me, please. Ryan, pick up. Now I want you to look. Can you see P and Q start from the same point? And this resultant point to what? Q. So how do I write this? Q minus P. The resultant is Q minus P. Okay, can you all write down? This resultant is Q minus P. Okay? So it's Q minus P. Now I want you to look again. All of you look, Hello. This one start from here, right? Then it continues, right? Then this one is the opposite, right? What do you think will be this? P plus Q, right? Can you see? I start again. P plus Q, right? Then will be this resultant. Okay? That means you must be able to recognize it. Everybody clear? That's why I've got to teach you. Clear? Okay, next one. Let's look at this. Right? All look up. Look here. This and this. By right, the resultant should be this, right? Okay, if the resultant is this, this will be P plus Q, okay? But now the direction is what? Opposite. So do you agree it's like that? Do you understand what I'm talking about? It's quite subtle, but you must know what I'm talking about. Everybody clear now? Okay, I'll repeat for all three again, so that you can be clearer. I'll repeat for all three again. Okay, all of you look. Let's look at this second part first. B is easier. All of you look up now. Don't look at the textbook, no use one. You copy also no use. Because exam it won't be the same. Can you see? I start. Then I continue. Then this is the resultant. Can you see? So this one must be P plus Q. Everybody okay? Everybody okay? Now, then you look, this is the same, This is P, right? This is Q, right? That resultant is this way, this is P plus Q, right? But now it's this way, you know. Can you see it's the opposite direction? So it must be minus this one, right? That's why the textbook give you minus P minus Q. You ask teacher if I leave like that, can. Understand? You're telling me it's the opposite of P minus P plus Q. Okay, now let's take a look at this. Can you see they start at the same point? And these two came out from the same point. Can you see? Once it comes up from the same point, that means most likely it's minus. Okay, then you look at this. It points to Q, so it must be Q minus P. Better now? Better now? Okay, I'm going to do the next one first. Let's take a look at the next two parts. Okay, all of you look up. I start from here, come. Then I continue here, right? Then this is the resultant in the opposite direction. What should this be? Q plus P, right? Can you see it? Can you see it's Q plus P? Okay, good. Then you think about this. All of you look up. Is this one plus this one, right? Actually, my resultant must be this way, right? So it's actually Q plus P. But because opposite, I'm going to put a negative, right? So it's negative Q, negative P. Are we okay? Are we okay? Okay, if you're okay, right, we'll practice. Okay, we'll practice. Can you look at practice now 8 at the next page? Can you write for me? Find the resultant. Find the resultant. Okay, let's take a look. B minus A, correct? Can you get B minus A? Yes, good. Next one. Good, what? A minus B, right? Correct? Because both of them start from the same place. How about this? N minus N. You remember to put the middle? Yes, good. This one? V plus W. Okay? Next one? Negative V plus W, right?
Yes.
Or negative V, negative W, right? Everybody okay? Can understand? Can, huh? Okay, good. Now, I am not going to go through example 9, 10, and 11. I will do it another time. Okay? Now, can you look at page 192 and complete number 7 for me? Same way. Number 7. Okay, done, huh? Done, huh? Okay, let's take a look now. Now, class, I know you are tired, but don't sleep, okay? I also want to sleep, but I cannot sleep now. Okay? This one is what? P minus Q. Next one? Q minus P, right? Okay, how about the next one? V minus A, right? Next one. B plus A or A plus B also can. Okay? How about this one? S minus R, right? This one? R plus S. Next one? Negative? N plus N, right? Agree or not? Yes or no? How about this one? N minus N. Everybody okay? Everybody okay? Alright, good. Now, then, can you take out one piece of the square paper that I have given you? Can you take out one piece of the square paper that I have given you? Can you look at question 9? Okay. Now, I want you to look at it carefully. Can you look at question 9? Can I borrow your square paper? Now, class, don't go and draw everything in the middle. I got enough because I'm going to draw quite a few. Can you just do 3 and then somewhere, because I need to do 7 and one more question inside. Question 9 and one more question, okay? Now, I want you to look at this particular question. On a sheet of squared paper, draw appropriate triangles to illustrate the following vector additions, A plus B. Now, I'm going to show you how I do A plus B. All of you look up. You need to draw A, B, C. Now, A is like that. So, we count 1, 2, 3, 4, 5. 1, 2, 3, right? So I'll have 1, 2, 3, 4, 5, 1, 2, 3. So this will be my A. Understand? Now, everybody look here, what's this? A plus B. That means when I stop, I got to draw B, right? Okay, look at B, what is it? 1, 2, 3, 4, 1, 2, right? So, let me just extend this a bit. Okay? 1, 2, 3, 4, 1, 2. That means my B will go. This is A, this is my B. Alright, what's my A plus B? This will be my A plus B. Do you understand? Can you understand? Who first? All look up. All look up. Then, you are supposed to draw for me B plus A plus C, and B plus C. Understand? Understand? Now, because it's plus, right? Whenever you end, it must start. Everybody, okay. Okay. Then, another one that you must do for me. Okay? All on the square paper, okay? All on the square paper. So, this is the first one that you must do for me. Question number 9. Now, can all of you look at question number 11 now? Number 11. This is number 11. Okay, I'm going to show you. All look up, all look up. The diagram shows 3 vectors A, B, C. On a sheet of squared paper, use the triangle law of vector subtraction to illustrate the vector subtraction. A minus B. Now, can you see A is here? I'm not going to do anything. Okay, you just draw it. Now, I told you, right? Listen carefully, don't talk, please. I say for subtraction, both vectors must start at the same point, right? So A is here, I've got to draw B. B is what? 1, 2, 1, 2, 3, wait. 1, 2, 3, then 1, 2, 3, 4, 5. So, 1, 2, 3, 1, 2, 3, 4, 5. So, I must actually draw like that, right? Correct. Now, I'm ignoring, can you please ignore these two? Can you see this one? Correct, this is my B, right? So, where's my A minus B? I must point this way, correct? Agree or not? Yes or no? Okay. All of you take out the square paper. Take out the square paper, this one. Okay. Then you start drawing. All of you look up. You must follow the vector that is given in the question. Now I repeat. All listen up, please. For question 9 is addition. Whenever you stop, you must start. For 11 is subtraction. Both vectors must start from the same point. Tomorrow I'll go through with you. Would that be okay? Can you please draw in pencil and not draw in pen? Understand? And please put the resultant A plus B or B plus A kind of thing. Okay? And resultant must be how many arrows? 2 arrows. Okay? So your only homework for today is 9 and 11. Draw on the square paper. Okay? Alright? Stop the video.